Hi, I want to give you a quick talk on databases. Databases come in two varieties, SQL and NoSQL. The original SQL was designed for very structured databases that were ideal for businesses that handle lots and lots of transactions. So SQL is the language, and the database servers that served SQL included Oracle, Microsoft SQL Server, and the open source version called MySQL, which was acquired by Oracle, and eventually MySQL was forked off and became MariaDB, and then a very light version called SQLITE. Postgres is also a SQL-based database, but they've added some enhancements to SQL to make it more modern, and so you see Postgres here as part of SQL. NoSQL was designed to handle internet data that were schemaless, that means unstructured, such as images, sound, text, and tweets. And so the major types of NoSQL databases include document, key value store, columnar, and graph. So for document databases, the common ones that are being used includes MongoDB and CouchDB. For key value store, Redis is a popular one, and typically you will also hear the word in memory because key value stores require quick lookup, and usually it's helpful to be in memory. And then Columnar is good for adding an entire column of data without touching the other columns, and this is good for summation, finding averages, and Cassandra is a popular option. And for graph database, Neo4j is one of the top choices for graph database. OLTP is a concept that uses SQL to perform queries and on transactional data, and this is done using SQL. OLAP analytics is used to create reports and to do what-if analysis. Typically, this is done using SQL joins, and now there are databases that are specialized to do this, including data lakes and data warehouses. Now, these databases that I just mentioned, Oracle, Microsoft SQL Server, and so forth, they all are software that runs as a relational database management system, RDBMS, and this is usually running on the hardware. And the hardware usually is also attached to a storage because you need to be able to store the data into storage. Now, when you're running this database for the users to use, you need to ensure that the hardware is backed up, that it can scale if more data and more users are joining the database. And also, at the very minimum, you need to ensure that you have your database backed up and to handle disaster recovery. And also, you need to be able to maintain the relational database either with updates or patches or security fixes. And so this relational database management system needs to be managed. And there are services out there now that offer to help you to manage all of this. So you don't need to buy the hardware, you don't need to update the relational database, you don't need to scale the hardware when more users are joining, and you don't have to worry about the backing of the database. And for services that offer to do all this for you, then we call that fully managed. Now, the concept of big data comes out because with all this internet data and with lots of traffic data being created, there needs to be a way to be able to use everyday common hardware to be able to quickly add compute and storage nodes. And then also you want to be able to do this and have it accessible across the planet. So this node on the left might be in the US, the one in the middle might be Europe, and the one on the right might be Asia Pac. And your users might also be spanning across the planet. So these databases need to be able to provide CRUD, be able to create, read, update, and delete entries into the database. But In this type of environment, also there is a concept of cap, where when you're designing this database that's going to be scaling globally, you need to consider three points when you're designing a database. And the 3 points are how consistent you want the database to be, how available you want the database to be, and how much partition tolerance, that is, if one of the nodes come down, will hamper the performance and accuracy of the database. And so this is the cap therein. And so the original database support atomic consistency, isolation, and durability, called ACID. So this is the case when you have a user very close to the database, and you can always ensure that the writing and reading of the data will be immediate, and it will be stored durably. But now with the databases now growing across, scaling across the planet, and for users to use it across the planet, the ACID property is becoming hard to conform to. It's hard to be consistent when a user updates a data here, and the database over here won't be able to get it until sometime later on. And so instead, the scaled database is now focused on basically available, eventually consistent. So the key focus is on availability, that the users can get to the data. It might not be extremely consistent and up to date, but the users will feel that the system at least is very smooth. And so these are some of the properties of the database, ACID versus base, that is pivots around the CAP theorem. Now, databases nowadays are all hosted in the cloud, and there's two reasons for this. Number one, you want your database to be managed by someone else. You want the scaling, and then the disaster recovery of your database to be managed in the cloud and by a managed service. And the second reason for databases now being hosted in the cloud is that your workloads now are also in the cloud, either virtual machines, containers, or serverless. You want these compute elements to be as close to the database as possible. And so you don't want that to be sitting somewhere outside, be connected to it, and you manage this. Rather, you want that database to be very close to where the users of the database are. And so that's the second reason why databases now are hosted in the cloud. Now, looking at the GenAI, the future database, GenAI can be used for one, the designing of the database schema. So just because NoSQL is schemaless, it doesn't mean that you should not be designing databases with schema in mind. With schema, you'll obtain performance, data consistency, and ease of use. And so even in the modern days of database, you still need to design a database, and GenAI will be a perfect companion for that. Two, once you design a database, you want to be able to deploy it. So over here, we can have it hosted locally, or we can have it hosted in a cloud, and you can use it through containers or virtual machines, and be able to also scale it and be able to have the right recipes or the right YAML file to be able to scale that automatically per need. And you can use GenAI to help you to do these. And third, when writing queries, depending on complexity of the data and the complexity of a query, writing SQL is no fun. And GenAI could be used to not only help you to write the query, but have it do it efficiently, so searches are faster. So this is a big nutshell of database. There are two different types, SQL and NoSQL, and the problems with big data scaling across ACID versus base, and now the need for cloud, because workloads are now located in cloud, as well as the management of the database. And finally, what GenAI can do for your database. You can use it for design of the database, deploy and scaling, and then finally querying of the database.